All right, so we're recording. I'll give you a minute then to try to set number 1 up, or number 11 up. All right, thanks, Alexandra. All right, let's see what we have set up. The one that I would hope is easy is if we go back to, we don't have it written out, at least I don't right now, but we talked about opposite sides. So like the left-hand side and the right-hand side are congruent. The top and the bottom sides should be congruent. When we look at the parallelogram that you're looking at in number 11, the 5y minus 2 and the 2y plus 13, they're opposite sides of each other. So not only are those parallel, which doesn't take a role into anything we're currently doing, but these should be congruent. So this side here and this side here should be congruent. Congruent then just means we can set those two expressions equal to each other and then go through and solve that. Not that the next one we're going to do here in a second is terribly hard, but I would hope that would be kind of the easiest one to understand, that those are congruent, set them equal, and then you can go through, solve this equation, and you should have ended up getting a 5. All right. Second equation. Let's say now I want to figure out what x is. So maybe a little harder, definitely new this year. You haven't seen it before. All right, Cam, how could we set that up? Good. So we referenced the idea that these diagonals are bisecting each other. So if they're bisecting each other, if this is the middle point of both of them, then what should be true is then this segment here should be the same length as this segment here. They should be equal to each other in terms of their lengths. So how'd you set that up, Cam? Good. So it's another statement where we're going to say they're equal to each other. And then that's the equation that we now work our way through to solve. Okay. So if I move that 6x over, we get 9 equals a 4x plus 5. Subtract 5. And did you get 1, Cam? Good. So we should get 1. All right. So that's hopefully not too bad. The one that did cause a little more problems yesterday were the angles. Now, the nice thing about this one, we don't give you any diagonals in this diagram because that seemed to be the confusion yesterday. So those have been pulled out. So let's not let those get in the way of our thought. Go ahead and try to get that started. We now have 3 different variables. Remember yesterday we talked about, and you should know this anyway, we don't want to be setting up an equation where you have multiple variables involved in these. So we clearly want to set up equations that have one and only one variable. So get 12 started. See what you think you could do with number 12. Do we want to work with the z's, the x's, or the y's at the beginning? Cool. All right, Rebecca, what'd you start up with then?
I did 4x minus 13 plus 2x plus 15.
Good. So she said 4x minus 13 has to equal 2x plus 15. And then what was your thought process behind that? But why'd you set them up like that? Why did you?
Because they're like across each other.
Good. So she said they're across from each other. These angles here. So these are what we would say are opposite angles. They're across from each other. All right. And then when we talked about, if I went back to the initial part of these notes, opposite angles in a parallelogram are congruent. So that's why she set them equal. All right. And then from there, hopefully we can go through solve this well. What'd you get, Rebecca?
I got x equals 4.
Good. So she gets 14. As we add that 13 over, we get 28 equals that 2x. So x should end up being 14. So that's a nice start. But if we now look, we still have to figure out y and z. So try to set something up now that would get us started on that. Like, how could we now get into figuring out what y and z are? Okay, anybody got a thought? Hope we can get this going. Yeah, Cam?
Okay, so I didn't finish solving it. Well, I noticed that 4x minus 13 and 10y minus 3 are consecutive. So we're going to solve them as 3, we're going to add them together.
Okay, so what Cam just said is he said this angle here, 4x minus 13, and the 10y minus a 3 are consecutive angles. So that means we should be able to add those together and set them equal to 180. Is that what you started to do?
Yep.
So
if there's an x and a y, it's not going to work. So you're going to plug in x equals 14, you're going to plug that into 4x minus 13.
good. So whether you can hear him or not, what he said is we could add these together right now and set them equal to 180. That is a correct thought. But if you didn't hear him, what he said is this doesn't work right now because we have x's and y's in the problem. So that doesn't do us any good in terms of solving this equation. But what he said we could then do, let's go ahead and take this 14 and plug it in for the x values so that we can actually figure out what these angles are. So if I go to this angle or this one, I'll use this one because it's the one that he talked about. If we plug in a 4 times a 14 now, so now let x actually equal that 14. So 4 times 14 minus a 13. Oh, what is that? 56 minus 13? Yes. Yeah, so we get 43. So this is a 43 degree angle. So now, instead of labeling that angle 4x minus 13, we don't need to worry about that being a different variable. 4x minus 13 evaluated, we now know is a 43 degree angle. So take the 43 degree angle, now add that angle that was defined in terms of y. The sum of these must be 180 since they're supplementary. Combine your like terms then. So 10y plus 40 equals the 180. And then should be on our way then. This is a nice one, so we get 140. Oh, well, that's convenient. Y is also 14. Okay. And then one last thought. So here's our x work. Here is our work for y. Now we need to figure out what our z is. What do we think for z? Yeah, Cam, what do you think? So what's z going to be? That's what I was afraid you're going to say, Cam. So here's what Cam just said. I'll give him a minute to think about it. He said that this angle here should be the same as this angle here, and I completely agree with that thought. But then he said they're both going to be 14. He's doing some calculating right now. Okay, and how'd you get that? Good. So he took the y, plugged it in right here, right? So if I did 10 times y, which we now know to be a 14, minus a 3, that's 137 degrees. So this overall angle is 137. And then he's right. These opposite angles are congruent. That's all z is the overall angle. So that would have to be 137 degrees for z. All right. See, these are fun. These are good. These make you think a little bit. And you got to know one to get to the other. It's got to be pretty systematic in your thought here.
Quick question.
Yeah.
To get that one, can we also subtract 43 from 180?
Yeah, good call. So what Cam just said is, so we like we said with a lot of these problems, this whole chapter, there are other routes you could take to get some of these. So what he just said is, before we knew that, once we identified that, let me clean this up just a little bit for his thought. Once we knew, so we went through all of this work, and eventually we got to a point where we knew that this angle right here was, no, I forgot, 43 degrees. So what he said is, couldn't we have just found Z, since these are consecutive angles? Consecutive angles are supplementary. So we said, couldn't we have just done 180 minus 43 and we could have gotten Z right away? And wouldn't that also give us 137 degrees that way? Yeah. So it's another good thought. Then think about what that would have led us to. So if that would have been your first thought, before we would have had our Y, couldn't we now have set up an equation where if we know these are congruent, couldn't we also have said 10y minus 3 equals 137? And that's still going to give you the y value of 14. So yeah, lots of different ways to approach these. Okay. Good. All right. Here's what I want you to do. Go through 13, 14. These should be the nice ones. So I'll give you 1 minute because I don't think this will take you too long. So do 13, 14, 15, and 16. So find those lengths. We'll give you 1 minute to do those. Those I think will be easy, I would hope. All right. Let's see where we are at with these. Not a lot of work to these. It's just kind of knowing our properties and then knowing what our numbers are. All right, so number 13, Ahmed, what did you put for the length of side BC right here? Good. Good. So he said this is 18 centimeters because I'm going to use a different word. The parallel nature doesn't necessarily matter. They're congruent. Opposite sides are congruent. So, yeah. So in a parallelogram, opposite sides are congruent. So if we know that this side here is 18, the opposite side would also have to be 18. Okay? All right. Ella, A, B, what would this length here have to be?
24.
Good. And that's why?
Because DC is parallel to it, so it's
Good. So here's our opposite side. And again, they're parallel, but not just parallel, they're congruent. Opposite sides are congruent. So this is 24. That's why she said this must also be 24. All right, so then we go to the orange. The next one, EB. So if I want EB, anybody think they got that length? Yeah, Cam. Good. So he says this is 13 centimeters. Why is that 13 centimeters? Good. So he's saying these diagonals bisect each other. So here's the length that I wanted here, EB. The diagonals of a parallelogram. So this diagonal here, and then the one that we're working with, this is the midpoint. Where they intersect is the middle. So if we know that this length here was 13, and this is the midpoint of that overall bigger diagonal, this would have to be 13 also. So that's where we get the 13 from. All right, and then last but not least, DB, now, Rebecca, would have to be what?
I guess 20.
So here's D. Here is B. So now you don't have to guess, right, Becca? Because here's 13. And then we got to continue all the way on over here with another 13. So it's just these two lengths added together. So what's 13? Yeah, so 26 centimeters. So once if they're the same, and then we want the full length of them, we just add those two bad boys up, and then that's got to be our overall length. Okay? All right, now the one I expect a little more issues with. Go through, I'll give you 2 minutes for this, see where we're at. Try 17, 18, 19, and 20 with all of our angles. And then as you guys start wrapping these up, I'm going to do a little exit quiz on this kind of a problem. So you'll want to get out your Chromebooks. Okay, it'll be for extra credit, so don't freak out about it. But as you're wrapping this up, pull out your Chromebooks so you can do that. Uh-oh. And yes, these should be a little bit harder. These should make you think a little bit. One of them in particular, I'd be very impressed if we got that angle. Okay, give you 1 more minute.
Yeah.
What is this thing doing? I don't know if my jacket's touching it or what. Okay, try this 1 more time.
I see that.
All right, so let's see where we are at. If you get the last one, that's pretty darn good. If you get any of them, it's better than yesterday, because yesterday this was proved to be hard for a lot of us, which is fine. So when I go to number 17, what I'm looking for is angle B, D, C. So here's B, here's D, here's C. So we're looking for this angle right here. All right, if I go from B to D to C. Remember, this is a parallelogram, so that means these are parallel lines. Your diagonals are your transversals. So I'm just going to draw in one of the transversals, the one that gives us this blue angle down here that we're concerned about. So thinking back, old quiz, old stuff, all that good thing, all that good stuff that we quiz on already. Aren't these inside of our parallel lines? And then if I look at this blue one, if I highlight this 20-degree angle up here, aren't these blue angles alternate sides of the transversal and both inside of the parallel lines? Those are your alternate interior angles. Alternate interior angles are congruent. So in this case, if the one is 20 degrees, the other one must be 20 degrees. All right, did we get that in here this time around? Yeah. Okay. Hopefully at home we're seeing that today a little better too. 18, DAB. So if I now want angle DAB, let me fill in this 20-degree angle just so we know it in case we need to use it later. It's not a bad thought on your own. So let's throw this as 20. We know this is 20. So now I want angle DAB. So DAB is this big angle up here. Okay, anybody think they got that one? This one we talked about a little today already. Yeah, Kim? Good. This has to be a 126-degree angle. How'd you know that? Yeah, so he said opposite angles are congruent. So if I look at its opposite angle would have been down here. That one you knew, the whole thing was 126. They're opposite of each other. They have to be congruent. So it has to be 126. All right, yeah, so then number 19, ABC. So let me clear these out. Let me write in what this one is up here. So we know that that big angle at the top is 126. And then the next question is ABC. So ABC is this big angle here. All right, what's your question, Kim? Yeah, anybody think they know it first? Ahmed, what do you think? So Ahmed said that this answer is 54 degrees. I agree with Ahmed, so now explain. Good. Oh, even, okay, Ahmed's getting real deep here. All right, so I like this. So what Ahmed just said is he used the idea of same side interior angles. So notice our two parallel lines that I have still highlighted in black. Wouldn't this all act as a transversal right here? So aren't those blue angles same side interior angles? And from our previous quiz, we know same side interior angles are supplementary. So that's why he did 180, took away the 126, and what he was left with was 54 degrees. I was not expecting those words to come out of his mouth, but 100% true. What I was, anybody else have a different way to explain this? Anybody else know what words I was expecting to come out of people's mouths? Consecutive angles, right? Isn't this angle here consecutive to this angle right here? And in a parallelogram, aren't consecutive angles supplementary? All right. So that would give us the exact same thought process that this has to be 54 degrees. So angle 50, ABC is 54 degrees. So now finally, the final little question, angle DBC. So D to B to C. So now I just want this part of this angle right here. What does that have to be? I just muted them. You guys want to get your Chromebooks out here so you have enough time. What does that angle have to be? Just that little one then, Ahmed. Good. Good. Didn't we just say this full angle was 54 degrees? So the entire thing is 54. If I used up 20 of it right here, then that would mean all I have left over for the smaller angle. So let me erase this. If my eraser will come on. It won't. Come on. Yeah, of course it's not going to work. That works. All right, so anyway, hopefully we understand that because I can't erase it. But if this was 54 overall, then 34 plus the 20 would make the total angle of 54 that we had found to be that previous answer. Okay. All right. So 2 things real quick. You do have homework tonight. It's just the next set of problems. All right. So if you go to the next 2 pages, that's your homework. You can get it here. It's also posted on Canvas. All right. You'll just do all this. It's basically the same stuff we just got doing. These properties of parallelogram. I think there was 14 questions. Yeah. All right. So that's homework for tomorrow. And then again, just this is extra credit. So we're not trying to catch anybody. We really kind of want to just